Welcome to the training for Production Scheduling Cloud. This is number 6 out of 12 presentations. In this lesson, we will discuss the schedule presentation in the Gantt chart and dispatch list, how to work in those components to analyze schedule quality aspects, and also how to perform manual scheduling changes. Let's start with the schedule views. The Gantt chart and dispatch list provide the following essential capabilities: presentation and visualization of the schedule, the ability to perform detailed schedule analysis, and mechanisms to adjust and fine-tune the schedule. Before discussing schedule analysis and schedule adjustment in more detail, let's understand why those are necessary at the first place. There are two main reasons why a scheduler may want to adjust the schedule. First, the schedule is calculated using heuristics, which arrive at good solutions in a reasonably fast manner. But those solutions typically are not globally optimal. Therefore, there will usually be some aspect of the schedule that the user may be able to improve upon manually. Second, even if the schedule calculation would deliver an optimal solution, such optimality is theoretical since it will exclusively be based on the data contained in the underlying scheduling model. But often the user will have additional information and insights that are not contained in the schedule's data set, and this intelligence may drive schedule adjustments. The work performed by the user in the Gantt chart and the dispatch list is generally done in an iterative manner. Analyzing the schedule and adjusting the schedule iteratively with the goal to arrive at a final schedule that can be published is how things are done. Now in the next section, we have a look at the various ways to analyze the schedule. Before you can make any reasonable schedule changes, you first have to understand the schedule and the various aspects of it. Knowing which work orders are late, which attribute sequences are good, which ones are less desirable, and how heavily the various resources are being used across the schedule horizon, and so on, are only a few aspects to evaluate. The first feature we look at helps to understand the schedule is lateness highlighting. This feature enables the user to immediately see all the operations that belong to late work orders, since they are then drawn in a darker red color. Here in the example, there's just one late work order. Knowing this can be the starting point to take manual scheduling action, for example, to resequence some operations or to perform offloading. Often you need to know some schedule details around a specific work order or when specific items are produced. The filter capability can be used for that. We add the filter by dropdown and the filter value field. The user can easily find operations of interest. In this example, all work orders whose number contain the string 60005 as a substring are shown in regular opacity, while the other non-matching operations are displayed in a dimmed manner. Evaluating attribute sequences is relevant for many customers and can be achieved via different means. One option is to specify a highlight attribute, which then shows all work order operations in their assigned attribute value colors. In this example, operations with the same family attribute value are shown in their assigned colors. Alternatively, attribute values are listed in the dispatch list, though there you see the values only one resource at a time. Further, using the tooltip on top of individual operations, Also allows finding the attribute value, but of course, always only one operation at a time. Now, when selecting an operation, then the selected operation is shown in red, and the task dependencies to upstream and downstream operations in that work order routing are shown via their respective links, thus providing the information about when the upstream and downstream dependent operations are scheduled. Now, this is an obvious one, but nevertheless relevant. Idle time, which corresponds to available capacity, is easy to identify via the white area on resources. Work order operations are typically shown as blue or differently colored boxes, depending on whether the attribute highlighting is active or not. The changeovers are drawn as the thin black bars, and calendar downtimes are displayed via the medium-sized yellow bars. Everything else is white space and corresponds to idle time. You can use resource groups to focus on only a subset of resources that are of interest for the analysis you want to perform at that point in time. The resources in resource groups can be sorted, which allows you to display the resources, for example, in an order that reflects the production flow on the shop floor. Now that we know how to analyze the schedule, let's go over ways to adjust the schedule. But before discussing the different manual schedule changes, we should understand that there are two distinct modes in which the calculation of the schedule is performed. First, the solve. When solve is used, then the schedule is recalculated from scratch, meaning that any previous manual schedule changes will be lost. Next, the repair. When repair is used, then most of the existing schedule is retained and only the changes made by the user are evaluated and propagated as necessary. Some changes made to a schedule or schedule data can be addressed via repair. Other changes will require a solve. Therefore, it's a good idea to first perform those changes that require a solve before making the changes that can be addressed via repair. A common action for a scheduler to adjust the schedule is via dragging and dropping an operation within the Gantt chart. This example shows how an operation is moved from one resource to an alternate resource, here from line 2 to line 3. The target resource, of course, must be a valid alternate defined in the work definition operation. If that is not the case, a warning message will be displayed and the change is not accepted. Now in the Gantt chart, you can add, edit, or delete resource downtimes in order to adjust the availability of resources. Here we see an example of adding a downtime. Such a calendar change always requires a solve, not a repair. So this is something you want to do earlier on in the schedule analysis and adjustment phase. Note that any calendar changes in production scheduling are not persisted across scheduling cycles, meaning they are not published back to Oracle Manufacturing Cloud. To edit or delete a downtime, select the downtime event, open the right mouse menu, and specify whatever you want, the appropriate option. Either edit or remove. In this example, the end time is shifted earlier by 2 hours, which corresponds to starting the subsequent shift 2 hours sooner than previously. Again, it's a calendar change, so this requires a solve. A repair is not sufficient. Some aspects of the schedule can also be adjusted via the dispatch list. By selecting a row or several consecutive rows and then using the up and down arrows, the scheduler can resequence operations. The moved operations and all those that were jumped by such resequencing is a block of operations. The first operation of this block will receive the start time from the previously first operation in that same block. The schedule repair will place the other operations of that block in adjacent manner and will also insert changeovers. Note though that at the beginning and at the end of that block, the changeovers may not be accurate. Also, the resequenced operations may overlap with subsequent operations, possibly because larger changeovers had to be inserted into the block of operations. Important to note also is that the up and down arrow is disabled for multi-capacity resources and possibly for unconstrained resources. Another schedule change that can be performed in the dispatch list is to edit the start time of a work order operation. This can also be solved via repair. Now, when a schedule is calculated, one of the drivers considered by the algorithms is the work order need by date. This is the time when the work order is ideally scheduled to complete. There can be situations where a scheduler may want to move a work order earlier or later. For example, when scheduling buckets and user-defined sequences are used, then it may be beneficial to ensure a specific work order to be scheduled in an earlier or later scheduling bucket, simply based on the job composition in the different buckets. Now, in this case, the need by date determines which scheduling bucket a work order is attempted to be scheduled in. If you need to change that, you can use the need by override date field to influence that. Note that this change also requires a code solve, not a repair. Finally, the need by override only lives within production scheduling, meaning it is not pushed back to Oracle Manufacturing Cloud. Now let's go ahead and perform some of the activities we discussed in this section. First, we'll look at some schedule analysis features, and then we point out the way to make some schedule changes. So let's open a schedule. We know for schedule analysis, we have the Gantt chart and the dispatch list. One of the first features to look at is maybe the usage of resource groups. As you see, I only see now the member resources that are assigned to this resource group. There could be several of them in there, and I could also sort them or organize them in a certain way, for example, to reflect the flow of product in the shop floor. Now, if I care about knowing where a specific work order is scheduled, or a group of work orders, or when certain items are produced, then I can use the filter by and the filter value feature. Now I'm looking for work orders that all start with a 43 or have a 403 in their code, and using the tooltip I see, okay, this is 4034 and this is a work order 4033, and you see it matches exactly the code. Now I'm more specific and therefore less work orders match. The matching one is shown in normal color. All the other ones are in a dimmed manner, with like lower opacity, but they are still accessible as objects, meaning I can still get information, I can still select them. Let's remove that. In addition, a way to analyze the sequence based on certain attributes, we can use the highlight attribute feature. On top of that, we can look at what's late via the highlight late button. If we had form work orders in this model, I could activate that as well. And then they would show up in like some light green color. We don't have any of that in this model. In the dispatch list, I get detailed information about which work order, operation, and item um, I have on the schedule on this resource, when they are being scheduled and when they are due, how long they run, how much they produce, and also I get information about the customer specific attributes. So this is the part about how to view and analyze and see the schedule. In terms of manual schedule actions, the first one to perform or to show is maybe the drag and drop. I can drag an operation on the same resource, or I can drag it on another resource, specify the precise start time if I want. And now you see that the repair button activated, and now I could submit a repair. I won't do that. I will just show a couple other changes. In the dispatch list, I can now, let's say in the injection mode number 2, let's say I pick that operation and I want to move this now up into the spot where I have created more time. So now this is a resequence operation, which I can also perform a repair on. And it is actually advisable to repair the schedule after each change to avoid getting conflicting manual schedule changes queued up that then may contradict one another during a repair. For specific operations, I could also go ahead and explicitly now change the start time of that by editing here the field. Let's say I want to do that a day later. So this would then be considered in the next repair solve as well. And now let's look at a couple changes that require a regular solve, which is triggered via the solve on the top right instead of the repair just above the Gantt. The need by override for a job, if I say I want this job to be due a week later, I can do that via this. And next time I run a solve, the underlying algorithms will aim to meet this state instead of the one a week earlier. Well, actually, this is in the future, so that date is actually a little bit too early. That would have to be moved into February sometime. Okay. This change requires a solve, not a repair. And similarly, the changes that I can perform on the calendar events, on the downtimes, also require a repair. So if I move the start time of this event earlier by, I don't know, let's say 4 hours, then this change now is essentially an extension of that calendar event. I send my Shopflow folks 4 hours earlier into the weekend. This is another change that requires a solve. So again, we just did a couple manual schedule changes, drag and drop, resequence down here, overriding this start time in the dispatch list, or those qualify for a repair, changing the override for the need by date, or calendar events require a solve. So that means that if I know about those changes I want to perform that require a solve, I should perform those first and only then spend time doing the manual scheduling activity that can be addressed via the repair. Now to summarize, in this lesson, we learned how to analyze and adjust the schedule using various features that are available within the schedule views. And we also learned which schedule changes require a solve versus repair.